Here we are in section 5-1, exercises 15 through 24. We're multiplying polynomials, and multiplying polynomials, that just means distributing because they have different terms. So let's do that. That's negative 16 r squared times r is r to the third power. We're adding exponents and there's a 1 right there. Y to the fifth. Notice we don't have to have like terms to multiply at all. So the next one is minus 28 r squared y to the, now here we have y to the fifth times y to the fifth. We're adding exponents, so that's y to the 10th. And then negative 4 times negative 4 is plus 16 r to the fourth y to the 15th. And again, those exponents of like things add, like variables add. Good. Number 16. Again, just distribute. We have 12x to the fifth, y to the fifth, and again that's x to the first and 4, that makes 5 of them, and then the y to the fifth just goes along for the ride. Plus 3 times 7, that's 21, x to the fourth, there are no other x's to combine with here, and y to the ninth. And then minus 12, x to the sixth, y to the 12th. Good. All right, number 17. Ooh, this one has two terms, so we've got to jump the s squared in first and distribute that, so we get an s to the sixth minus 2s to the fourth plus 5s squared. Good. And then this guy jumps in, the minus 1, and we get minus s to the fourth plus 2s squared minus 5. So the end result of that whole thing is, let's write it in a different color down there, s to the sixth minus 2s to the fourth minus s to the fourth is minus 3s to the fourth plus 7s squared minus s. Nope, that's not an s. That is indeed a 5. There we go. Ooh, s's and 5's look a lot alike. All right, let's do number 18. Oh, we've got another binomial times trinomial. Now notice what we had over here. Binomial times trinomial gave us 1, 2, 3, 4, 5, 6 different terms, and some of them combined. Same thing will happen over here. We got to jump the r all the way through, so we get r cubed, that's r times r squared, minus 2r squared plus 3r. Now when we jump another one through, such as let's pick a different color over there. The 3 goes through like that, and we get plus 3r squared minus 6r, and then plus 9. So this guy jumps through with that color, and then we get, as a result, let's go back and put the results in orange. We get r cubed plus 1r squared minus 3r plus a 9, and combine those like terms, and it went from the 6 terms simplified down to 4 terms. Good. All right, so number 19, distribute the f and we get f squared minus 3f. Distribute the 1 and we get plus f minus 3. I guess we could have written it right next to there. And what does that get for our solution there? Our answer, f squared minus 2f minus 3. Good. Number 20. We're going to jump the g through and we get g squared plus 6g. Then we jump the negative 2 through and we get minus 2g minus 12. And then our answer then would be g squared. These two go together, plus 4g minus 12. Good deal. Okay, let's try negative h squared. We've got to jump that guy through. Super distribute here with both of those terms. We get positive 2h to the fourth, and then plus 3h cubed. And then take this 4h and distribute that guy in, and we get minus 8h cubed minus 12h squared. Combine the like terms, we have 2h to the fourth. These two are like terms, go together. That's a minus 5h cubed minus 12h squared. And there's our answer to number 21. All right, number 22. Jump this guy through, and we get 12j to the fifth plus 3j cubed. Now jump the next one through, and we get minus 8j cubed minus 2j, I think is what that'll be. Yeah. All right. Now let's simplify them together here. Any like terms? Oh yeah, that guy and that guy. So we have 12j to the fifth plus, minus. So we got a plus 3 and a minus 8, so that's a minus 5j cubed minus 2j. Good deal. Notice these binomial times binomials give us 4 terms here, and the 4 terms then simplified down off into 3. All right, but not always, but in these cases they have been doing that. All right, number 23. J squared minus 8j. And then the next one is that and that, so plus 8j minus 64. Ooh, notice what happened there. Those guys actually, when they combine, go to 0, so we just end up with j squared minus 64. Fascinating. Look at that magic happen in there, that we had a plus 8 and a minus 8 in there. Okay, number 24. The 2k goes through and we get 4k squared minus 8k. And then the next 4 goes through and we get plus 8k minus 16. I think the universe is trying to tell us something here. Look at this pattern. Whenever they're exactly the same, but one's a plus and a minus, we start to identify that, hey, we get it down to the two middle term cancel, and we just get the subtraction of 2j squared and 64, 4k squared and 16. Good.